Alright, good morning, Osiris. I'm gonna take this video here to show you how I'm assembling the wax bonder gasket, and yeah, hopefully you can let me know if you have any suggestions or anything. Before I begin, the one thing I want to show you on here is these standoffs. One of them was, let's see, yeah, it looks like this one here. You can see that. See how it's like you can see a gap in there, like right there at that gap. So the lower one is like beveled down, and I'm not sure. There's a good image of it. I don't know why that is. It's clearly been manually sanded. So that one was kind of bent, and I used a different screw to connect the two pieces together, and then now it's straighter. But I'm not sure why that was manually sanded, and some of the other ones look sanded as well, although that's the most prominent one. And then the other thing I did is I added some additional washers here so the plunger does not move up quite as high, so hopefully that'll reduce the upward deflection, because based on the way the gasket looks, the previous one, it appeared that it was tearing on the upward stroke. So anyway, that's a question I have for you. I'm not sure what that's all about, but here, if you can see, I got the pieces here. Try to make it. Let's see. So I'm gonna first start by putting the gasket, installing it on this piece here. Let's see. Got my precious new gasket. Yeah, put that there. So got my ring. Put that there. And I have all my little mounting bolts. And what I've done actually, these bolts that secure the ring down to that secure the ring to the chuck, then I noticed that after a few cycles they would be loose. So I put some little lock washers. I don't know why they're loosening. I don't know if that's related to the fact that this is aluminum and it's expanding and contracting, or if it's somehow the gasket is getting seated. And once that happens, then they need to be retightened. But I noticed that if they're even slightly loose, then that causes a leak. Because when I tighten them, there was a while where I was only getting like 0.6 bar or something like that, or yeah, 0.4 bar or something, and then I tightened them and went back to the full 0.8 bar, which is what our vacuum pump is capable of. So so that's another problem. So we're gonna actually have one of these rings fabricated. Why is it made out of aluminum? That's one of the questions I have. It seems like, you know, this is made out of something much harder, maybe stainless, but the ring itself is a little bit more flimsy. So put all those screws in there. I'm just going to get them all seated initially, and then I'll tighten them in an alternating pattern. Okay, so all the screws are seated. And now I'm going to tighten them down. Again, like I said, going in a cross pattern. So they're getting pretty tight now. Give them one last good crank on there. Because like I said, I noticed that unless these are really tight, then I get a leakage there. Really want to crimp down hard on that gasket. And also the tears that we've been having are not been occurring where the gasket is crimped down. It's been occurring at the where the gasket flexes. So I don't have any concerns about tightening these really hard. It's about where it flexes, that's where it tears, which is not being crimped at all in any location. It's in between this piece and this ring. The interface in between there where it bends is always where it tears. Okay, so those are all tight now. Got this secured on there. Let's see. Okay. So now what I'm going to do is put this ring here. I just need to mark it, I think. I'm trying to mark a little. Yeah, so I'm just going to place this on here, like that. Get a little flex in the gasket. And now I'm going to take this piece here and put it on top. I always find this to be very annoying, connecting these vacuum lines. Let's see. Number So I've connected all the vacuum lines. The one thing I wanted to comment too on the vacuum lines is they're obviously made out of something that's not able to withstand the appropriate temperatures because they've melted in the past. So, and it appears that the replacement ones that were sent are the exact same as the ones that are in there. So I don't know what that's all about, but there should be definitely, I mean, if the tool is rated to 200C, then I think the vacuum line should be at least capable of that. Yeah, because we've had leaks in the past, and it was because there were holes in the vacuum lines. So now that I got all those things assembled, I'm going to put in these outer screws. And then just cinch them down, and again I'll cinch them all down, and then I'll tighten them in a alternating pattern. Okay, so that basically does it. Last thing I have to do is put this on. It only takes a second. It's not really critical. that does it. Yeah, thanks for watching. Let me know if there's any suggestions you have. It seems like a pretty simple thing, but you know, I'm not sure if there's anything that I'm doing wrong. Obviously, we had one gasket in here that lasted for a really long time, and then since we started changing the gaskets after that first one tore, we've gone through 3. This is now the 4th one that we'll be starting on in a period of like a month or so. So I don't know if it's something I'm doing wrong with the install or what, but it seems pretty straightforward. So let me know if you have any recommendations or what you think could be causing the issue. I know, like I said, the bent standoff was not good because having it being bent means that the plunger goes up too far in that one area and also unevenly, which overstresses the gasket. And obviously if it's, you know, off by a millimeter, that's a big deal, because I think that I measured the whole stroke length up and down was like 6 millimeters. And from the point where the gasket is completely, where the inner chuck and the outer chuck are at the same level as far as the gasket's concerned, it only goes up about 2.5 millimeters from that point. So if it goes up 3.5, that's a big change. So that could potentially be causing it to tear. And then also that aluminum ring, I don't know if I mentioned before, I said is warped. I think that's from the heat. But if that's, you know, warped and that causes, you know, if it's warped and it's off by a millimeter in one location, then that's going to be a big deal in terms of changing the amount that gasket flexes. So that could definitely be a problem. And like I said, we're getting another one manufactured out of stainless, so to try to prevent that warpage. We had been using 135 degrees for the hot plate temperature for bonding with the Emerald bond, and then we are also tried using more recently a material from Brewer Sciences called HT-10.11, and that required a higher bonding temperature of 170 degrees. So I don't know if that caused the warpage, which potentially caused the misalignment leading to the gasket failure, but I thought the tool was rated to 200, so maybe it's worthwhile in the future manufacturing that ring out of something other than aluminum. So, okay, thanks a lot. Let me know what your recommendations are. Bye.